Many questions asked based on spin-only magnetic moment calculation from coordination compounds. Hello students, let us start. Paramagnetic nature, weakly attracted by magnetic field, contains unpaired electrons. Diamagnetic nature, weakly repelled by magnetic field, contains zero unpaired electrons. In presence of strong ligand, pairing occurs. Spin-only magnetic moment formula under root n into n plus 2 Bohr magneton, where n is equal to number of unpaired electrons. When paramagnetic substance is placed on weighing machine where magnetic field is induced, then weight of the substance increases because of attraction towards magnetic field. Due to attraction from magnetic field, and weight of diamagnetic substance decreases due to repulsion from magnetic field. If you place under weighing machine where magnetic field already assigned, in such cases paramagnetic substance weight increases, diamagnetic substance weight decreases. Ferromagnetic substances are strongly attracted by magnetic field. Iron, cobalt, nickel, Fe3O4, FeWO4. FeWO4 is tungsten oxide. So let us see JEE Mains 2026, 28 January shift 2. Question based on magnetic moment calculation. So let us see question here. Everyone read once question here. How we need to calculate, what is the common criteria we use here, see. So first of all, they are asking about correct increasing order of spin-only magnetic moment values for the complex ions. Okay. So here we know magnetic moment directly proportional to number of unpaired electrons. So number of unpaired electrons increases, spin-only magnetic moment value automatically increases, right? So in the given question, one by one if you see here, one by one if you see, the first complex, what is first complex here? First complex, that is manganese, it is in +2 state, which is tetrahedral. Why it is tetrahedral? Weak ligand, right? It is. So weak ligand here, no pairing occurs, no inner d orbital. So what we write here, it is coordination number 4. So we specified as tetrahedral. Weak ligand, first of all, tetrahedral, that is weak ligand. So now if it is weak ligand, no pairing occurs, we know that. So Mn plus 2 according to configuration, according to Mn plus 2 configuration, observe it. How many unpaired electrons we are going to get here? 5 unpaired electrons you will get here. Unpaired electrons is equal to 5. Okay. Next, similarly, if you take CuH2O plus 2, CuH2O plus 2, which are again weak ligand, so no pairing, again coordination number, what is coordination number is 6 here. Coordination number 6, that is octahedral complex. So weak ligand, anyway no pairing here. So copper plus 2. So copper plus 2, it is having 1 unpaired electron. 1 unpaired electron. Next, another complex, see here Cu plus 2 done, Ni is plus 2. If it is Ni plus 2 configuration, so Ni plus 2 is strong ligand, here it is. So pairing occurs. Pairing occurs. If pairing occurs, inner D complex formed, low spin complex is formed. So in this case, 0 unpaired electrons. You can specify 0 unpaired electrons. See, every time same concept, 0 unpaired electrons. Strong ligand, pairing occurs. Then another one, after completion of nickel, nickel along with weak field ligand. Nickel plus 2, weak field ligand. So weak field ligand, how many? Coordination number 6. High spin complex where unpaired electrons are how many? Unpaired electrons is equal to 2 here. So now overall see here, unpaired electron here it is 5, 1, 0, 2. So based on the given values, you see now what are the options matching with that. First, manganese having 5 unpaired electrons, that is A here. Manganese is A, 5 unpaired electrons. So highest value, that is A here, fine. Here also first option also A. Among 1 and 2 answer should be. After that, 2 unpaired electrons, that is D. 2 unpaired electrons D. Here you can directly differentiate, answer should be 2. Right. Next question. Identify the metal ions among having spin-only magnetic moment value more than 3. Sum of unpaired electrons present in high spin octahedral complex formed by those metal ions. See, they specified already magnetic moment value more than 3. See, generally, if magnetic moment value that is more than 3 bm, meaning unpaired electrons, if you see according to formula, unpaired electrons greater than or equal to 3. So we need to find here such complexes where sum of unpaired electrons present in the high spin octahedral complex. Okay, we need to find unpaired electrons. So observe it now. Complexes one by one. First it is CO plus 2 complex. So if it is CO plus 2 complex, we know it is a D7. Which complex it is? High spin complex they mentioned everywhere. High spin complex meaning it is inner D complex. High spin meaning more unpaired electrons present. Outer D complex, no doubt. So here unpaired electrons 3 you will get. Unpaired. If 3 unpaired electrons here. Okay. So 3 unpaired electrons here, Bohr magneton mu net value here you will get around 3.87 if you apply formula. Similarly, nickel plus 2 configuration is D8. Nickel plus 2 unpaired electrons. So here mu net value that is 2.83. And then third compound Fe plus 2 given. So in Fe plus 2 what they mention? Fe plus 2 configuration, there is a D6 configuration. So unpaired electrons 4. So mu net is equal to 4.90. Next, vanadium plus 3 configuration, that is D2 configuration, 2 unpaired electrons. So then mu net is equal to 2.83. Fifth one, that is titanium plus 2 configuration D2, where 2 unpaired electrons present. So mu net is equal to 2.83. Mu net is 2.83. So overall, after comparison of all these values, sum of unpaired electrons present in the high spin octahedral complexes found by those metal ions where spin only magnetic moment value greater than 3. 1 greater than 3. How many values we need to see here? 1, 2, only 2 values. Only 2 values with greater than 3. So in those complexes, how many unpaired electrons present here? 3 here, 4 here. So overall unpaired electrons in such complexes, so 4 plus 3, overall we are getting 7 unpaired electrons in those complexes. Hence answer is 7 for this. I hope everyone clear with these questions. For more videos, follow the channel. Thank you. Thank you very much.